All right, so this video is going to go over pages 29 through 32 in your packet. We're going to talk about some terminology in 2D waves. So 2D waves can exist as a plane or a circular wave. So a plane would be like if you were to look down at waves from like a bird's eye view, basically you'd see like these little lines, okay, and they're usually heading towards shore. Okay, so the velocity is heading to the right in this case, or whichever way the waves are going. Okay, so that would be a plane wave. Okay, and then your circular wave would be something like if you were to drop something in the water and create that ripple effect, okay, where you get basically the endless amounts of circles that are going out from the source. Okay, so your velocity could be going this way, it could be going this way. Okay, so your velocity is in all directions in this case, so that would be a circular wave. Now, a couple of terms we're going to talk about is a wave front. So a wave front is the surface on which all the points are in phase with their motion. So usually that means is if you look at this diagram right here, your wave front is usually on that crest line. Okay, that's where everything lines up, and that's basically the front of your next new wave. Okay, now your wave ray is the direction that that front is going. Okay, so think about it as if I drew a plane wave like this, and I just drew some lines. If I didn't have a wave ray, I would have no idea what's going on. I would have no idea which way they're going. Okay, so the purpose of that wave ray, like here, okay, is to tell us where the wave front is heading. So if it's a plane wave, so this would be a plane wave right here, we know it's going in that direction of the ray. Okay, a circular motion, its rays are going in all directions. Okay, so it just depends on where that wave front is. So like at this moment right here, okay, right there, that would be your wave front, and it's heading this way. Okay, or if you had right here, this would be your wave front, and your wave ray is heading that way. Okay, so the ray just basically tells us which way the wave front is going. Regardless of it, the wave ray is always going to be perpendicular to the wave front. Okay, so those are going to always be perpendicular. Okay, so I'm not going to really worry about this part right here, about the propagation of waves. Remember, propagation just means the movement of waves through a medium. Okay, so nothing too crazy there, but we're going to talk about some wave properties. The first one, you've definitely heard it before, it's reflection. Okay, but this is a little more specific when we're talking about waves. So when water waves are reflected, they obey the laws of reflection. The angle of incidence is equal to the angle of reflection. Okay, so if you have, say, like a wall right here, okay, and you have a water wave going in towards the wall, what it's going to do is it's going to reflect off that wall at the same angle that it came in at. Okay, so the way we do that is we use this normal line right here. Okay, so the normal line is basically a line that we use as perpendicular to the surface, okay, that it bounces off of, and that'll help us determine what our angle is. Okay, so there's two types of reflections. You have specular reflection, which we just kind of talked about. That's where it bounces off a nice smooth surface, and your incident angle is going to be equal to your reflection angle. Okay, so remember, incident basically means incoming. Okay, so you can try to remember that. Incidence is basically your incoming wave, and then your reflective wave is the one that's actually bouncing off. Okay, so in specular reflection, everything's nice and good. It bounces off the same angle. It's a nice smooth surface. But occasionally when you talk about bouncing off a surface that's not smooth, that would be diffuse reflection. Okay, that would be like, say I had like the same water wave, but now what I'm going to do is I'm going to make the wall kind of look like this. Okay, so it's not smooth. So if I had a wave come in, okay, well, if it hit this part right here, it may come back at this angle. Okay, or if I had a water wave come in and hit right there, it may go off at that angle. Okay, so a diffuse reflection is basically when it doesn't really bounce off the way you want it to because it runs into a rough surface. Okay, so what is the definition of normal in reference to the angles in reflection? Okay, so one, it is always perpendicular to the barrier or whatever it's bouncing off. Okay, and then it divides, your angle of incidence and your angle of reflection in two equal parts. Okay, moving on to the next one, we have refraction. So be careful with this. This is not rarefaction. So remember, rarefaction was on a longitudinal wave where everything, when it stretches out, that's a rarefaction. Refraction happens when waves pass from one medium to another. Okay, so what happens is the speed of a wave changes when it changes the medium. So like if you go from like air to water, water to air, you're changing your medium. Okay, so like an example would be like if you put your legs in the pool and you angle them out and you look down, it looks like your legs are almost fractured. Okay, so that would be refraction. Okay, so that's the way you can kind of think about it, is that your legs look fractured in the pool because of that bending of light. Okay, because the air looks your legs in the air look different than your legs in the water because the medium is different. Okay, or if you put like right here, if you put a pencil in water diagonally, okay, it's not going to look like it's connected. Okay, because the refraction. So when you go from a less dense to more dense, so this would be less to more. Okay, what's going to happen is you have your normal line right here. The normal line is like we just looked at. Okay, so this ray, this is your incoming ray right here. Once it hits that water, what's going to happen is if it goes from less dense to more dense, this angle is going to get real close to that normal line. Okay, so it's going to get a lot tighter to that normal line. So let me draw a better option of this. So let's draw my medium. So let's say the bottom is water, the top is air. Here is my normal line. Okay, so let's say I have a wave coming in at this angle. And once it hits that water, what's going to happen is if it's more dense, it's going to get a lot closer to that normal line. So that angle is going to get a lot smaller. Okay. Now, if you went from a more dense to less dense, so let's say now the top is water and the bottom is air. Okay. You have your angle coming in. That's going to stay the same. But now once you hit when you hear less dense, it gets a lot easier and it gets a lot faster. So it's going to get further away from that normal line. So that angle is going to get a lot bigger. Okay. So slower mediums cause the light to bend towards the normal line. So if you go to a more dense medium, that's going to slow you down. It's going to make that angle go towards the normal line. Okay, if you go to a less dense, okay, it's going to get faster, okay, which is going to make that angle go away from the normal line. So refraction depends on what property? So that's going to depend on the speed of light in that medium. And it's also going to be determined by the wavelength of that light. Now, diffraction. So diffraction is the bending of waves around corners without a change in the wave's speed. So diffraction is more prominent if the slit or obstacle is comparable in size to the wavelength. The narrower the slit, the more the waves spread out from it. Okay, so what happens is, I talk about this in my class, is if you're down the hall and I have my door open, okay, the reason why you can sometimes hear me is because of diffraction. Okay, basically is if I'm standing near the door, so let's say I'm right here. Okay, so my sound waves are traveling towards the door. So let's say this is my wall. That's the door. The opening right there is the door. Okay, so it's going to go towards the door. And what's going to happen is it's going to start cramming in here real tight at that door. And once it gets out, okay, it's going to spread out. So now it's no longer going to be nice and it's not going to look like a plane. What's going to happen is it's going to start spreading out like this. Okay, so if you are over here, okay, there's a reason. That's why you can hear my voice, is because of that diffraction. Those waves are going through the door or the opening, and once they get through, they spread out and head in all directions. Okay, so that is diffraction. Interference, so this should be more of a review. So interference is when you have two or more waves overlap. Okay, so that means two or more waves come in contact with each other. So there's two types. We talked about constructive and destructive. So constructive is when you have two things come together and they make each other bigger, and destructive is when you have two opposite things come together and they try to cancel each other out. So these little solid lines right here, that's a crest. Okay, that's a crest of a wave. And then the parts in the middle, that is going to be the trough. Okay, so if we look at scenario number 1, like right here, okay, you see a solid line meets a solid line. See right here, you see a crest hits a crest, and you get an even bigger crest. Okay, so that would be constructive interference. Okay, and then over here, scenario number 2, you see two middle spaces meeting up. So that's a trough meeting a trough, so you get an even bigger trough. So both of these are constructive because they're making each other bigger. Okay, and then in scenario number 3, you have a crest meeting a trough, and that's going to cancel out, so that would be destructive interference. So remember when we talked about a node and an antinode when two waves meet up? A node was when you had no amplitude. Okay, so the only time a node is going to happen is when it's destructive. So right here, this would be a node. Okay, and an antinode is when you actually have the opposite. That is when you're going to have maximum amplitude. Okay, so that would be constructive where those wave gets bigger. Okay, so that would be an antinode. Okay, the next wave is just going to be another visual. Okay, so you've got your solid line as a crest, your dotted line as a trough. Okay, so if you look at when do you have a crest meeting a crest, so like right here, that would be a crest and a crest. Okay, so that would be constructive interference, so that would be an antinode. Okay, or right here, this would be a trough meeting a trough. Okay, so that would make an even bigger trough, so that'd be constructive as well, and also an antinode. Okay, but what happens when you meet a crest and a trough like right here? That is going to be destructive interference where they're going to cancel each other out, and that's going to make a node. And that'll end that one.